So when you read this problem, just kind of reading this, what this says, it says p of x equals 4x to the third plus 3x squared plus 2x plus 1. It says find p of negative 2. What does that mean? Yeah, it means that x is negative 2. So literally, if I were to put p of negative 2 into words, like the words that it actually means is the function p evaluated when x equals 2. Sorry, x equals negative 2. Like that is literally what that, like p of negative 2 translates into. So it's just it's a shorthanded math way to write all of those words without actually having to like write all of those words. Because we're kind of lazy people and we don't want to write everything out. So that's literally what p of negative 2 means, is to evaluate the function p when x equals negative 2. Typically we don't see p of x. What do we most commonly see here? F of x. F of x. Sometimes we see g of x. That's like the second most frequent one. Then that doesn't mean you can't see others. They're not excluded. Those are the ones that are normal ones. And really, f of x is the same thing as what? Y. So f of x, g of x, p of x, they all just mean y. It's a fancy note. It's called function notation. Just a way of writing y without actually writing y. So for this problem, let's plug that in. Let's evaluate that because we're going to be doing that a little bit today, and I just want to practice it because we haven't done it in a while. So our function is 4x to the third plus 3x squared plus 2x plus 1. And instead of x, I'm replacing that with what? Negative 2. It is imperative that at this point in your lives, you get in the habit of, if you take out a variable and you put in a number, you need to put it in parentheses. That is something that should be second nature to you. You should not need to be reminded of that. But it's imperative because if you don't, then especially when you start plugging things in and typing it in the calculator, you're going to get different answers depending on your parentheses, if you use them or don't use them. Not always, but enough times that if you need to just always use them. So if you don't believe me, then you can type in negative 2 squared with parentheses and negative 2 squared without parentheses, and you will get two different answers for that. One is correct and one is not. So that's why we just always use them. So let's do the math on this because I think we can do the math without a lot of trouble. So negative 2 cubed, because we start with our exponents, what's negative 2 times negative 2 times negative 2? Negative 8. So this is now 4 times negative 8. Okay, what about negative 2 squared? 4, and it's positive. Plus, okay, it says 2 times negative 2. What's 2 times negative 2? Negative 4, and then plus 1. And then just doing some math, 4 times negative 8 would give us negative 32. 3 times 4 is, and then plus negative 4 is the same thing as minus 4. Plus 1, so just doing our math, negative 32 plus 12, negative 20, minus 4, negative 24 plus 1, okay, so this would give us negative 23. So what we would say is that p of negative 2 equals negative 23. Oops, sorry, that means that when we plug in negative 2, we should get out negative 23. Okay, so on 396, we are starting with synthetic division. We are going to do problem 6. All right, so synthetic division. There's two things you need to know about it. The first thing is that it only involves coefficients. It only uses the coefficients. So that's nice because we don't have any variables we have to write down as we do our work. Yay! I don't know if you're excited about that. I get excited about that. The second thing you need to know about it is that it only works, because we said it doesn't work all the time, it only works some of the time. It only works if you're dividing by something like x minus a. So synthetic division only works if you're dividing by something like x minus a. It only works if you're dividing by something like x minus a. So what I mean by that is like you can't be dividing by x squared or x to the third or even like 5x. It only works if it's just like 1x and that's it. Okay? So we're going to draw a weird like partial looking rectangle thing there. And inside the rectangle, I'm going to write 2, 5, -1, and 7. Inside is 2, 5, -1, and 7. Where did those numbers come from? Yeah, the coefficients of the first parentheses. So all these numbers that were inside, the 2, 5, -1, and 7 all came from here. Okay, and then outside, I'm going to write 2. Where do you think that came from? What's wrong with it? It's the opposite sign. This number will always be the opposite sign. Okay? This number will always be the opposite sign. Okay, are you prepared for synthetic division?
Sure.
All it requires you to do is multiply and add. Can you multiply and add?
Maybe.
Then you can do synthetic division. You're questionable on everything, so this is nothing new. I'm just kidding. Yes, ma'am.
So the 2 is the other parentheses, but it's just
It's the opposite sign.
Okay, so you're not taking it from that other 2.
No, that's why I did it in blue and did that in blue. So I was smart about that one because I was like, that can be a little confusing because there's a lot of 2's in this problem. Okay, so first thing I'm going to do is I'm going to bring down this 2. Every time. The very first thing you do is you bring down that 2. Whatever that number is, you bring it down. And this is where things get a little bit weird. So remember I said we were going to do 2 things. We're going to multiply and add. First thing we're going to do is we're going to multiply 2 times 2. What's 2 times 2?
4.
And now I'm going to add. What's 5 plus 4?
9.
Okay. And I repeat that process over and over and over again until I run out of things to do. So now I'm going to multiply 9 times 2. What's 9 times 2? Okay, so I have -1 plus 18, which is 17. And I'm going to repeat that process again. 17 times 2 is, and 7 plus 34 is 41. Do you think I keep going or do I stop here? And why do I stop? There's no more numbers. I've done my division. It's done. You start from the end, and you always start from the right side and work your way back. The last number is your remainder. The next number is your constant. What does it mean to be a constant?
No x.
No variable attached to it. So what do you think 9 is? X. And what do you think 2 is? X squared. So this means if I were to physically do long division of 2x cubed plus 5x squared minus x plus 7 divided by x minus 2, my answer would be 2x squared plus 9x plus 17. And remember yesterday we learned to write our remainder as plus 41 over x minus 2. That's my answer. Okay, so we've got our problem set up. And again, it's -1/3 because we always use the opposite sign of what's in the parentheses. All right, so what's the first thing I'm going to do for this problem? Bring down the 6. And now I'm going to multiply that 6 by negative 1/3. So what is 6 times negative 1/3? Negative 2. And what do I do with negative 25 and negative 2? Add them, and I get negative 27. And as long as you know that process, you just keep repeating that process over and over and over again. So you multiply times negative 1/3. Negative 9 or positive 9? Positive. And then 0 plus 9 is? Okay. Then I do the same thing. 9 times negative 1/3 is negative 3. Negative 3 plus 3 is negative 6. A negative 3 and a negative 3 is negative 6. Happens all the time. You're good. Okay, and then negative 6 times negative 1/3. 2. Positive or negative? Positive 2, and then 5 plus 2 is? Okay, so starting from the very end, starting from the right side, what is 7? Okay, then negative 6. Okay, 9. Negative 27. And then positive 6. Okay, so that means that my answer is 6x cubed minus 27x squared plus 9x minus 6 plus 7 divided by x plus 1/3. We go back to whatever the original, whatever divisor, dividend, whichever one that is. I don't know. The vocabulary escapes me. Clearly it's important for you to learn it in life. Okay, so our coefficients that are going to go inside, we have 2, 8, 0, 2, and 8. We have to put the 0 in here to fill in for our x to the second. And then outside, we're going to put negative 4. So doing our math, bring down our 2. And then we multiply 2 times negative 4, which would be negative 8. Negative 8 and 8 gives us 0. And then we multiply 0 times negative 4, which is 0. And then 0 and 0 gives us 0. And again, 0 times negative 4 is 0. And then 2 plus 0 is 2. And then 2 times negative 4 is negative 8. And 8 minus 8 is 0. So we have to be very diligent that we pay attention to what our exponents, what's happening to them. That it goes from 4 to 3 to 1 to none, so we skip 2. So we've got to make sure we fill that space in. So what is our remainder in this problem?
0.
Is that okay?
Yes.
So what does that mean if we get a remainder of 0? It does. And this is our constant. This is x. This is, and this is, okay. All right, so that means my answer that I end up with is just 2x cubed plus 2. Okay, I'm going to do something completely random, okay? But trust me. So we have 2x to the 4th, and you don't have to write this down necessarily. You can talk me through it. Plus 8x to the 3rd plus 2x plus 8. Factor this. Okay, how many terms does it have?
4.
So I factor by, okay, so here's my first group. Here's my second group. What does the first group have in common? 2x cubed. And if I factor that out, I'm left with?
Do you want us to write this?
Okay. What about the second one? 2x plus 8, what do they have in common?
2.
And what's left over?
X plus 4.
So then your final factorization would be what?
2x cubed. Oh my god. Go home. Honestly, I would love to go right now.
What do you notice about that factorization?
Oh my god. You can take something else. For real?
You could technically GCF again. You could factor out a 2. But here's what I want you to notice. When I divided by x plus 4, I was left with 2x cubed plus 2. So the reason I got a remainder of 0 was because that means it actually factors. So I want you to go back to page 396. And we're going to do something very random, but trust me. I'm going to take my original function, which was 2x cubed plus 5x squared minus x plus 7. And we are going to plug in 2. Where did that 2 come from? Yeah, it's the outside number, the thing I synthetically divided by. So we're going to plug that in. If you want to, you can just use your calculators because I know some of you have them. So go ahead, just type it all in for me.
41.
Okay, so when you plug all of this in, it gives you 41.
And that's your remainder?
Yep.
What?
That is your remainder. And that works every single time. Every time.
Why would we need to know that?
Okay, so that's a great question. So that means, let's look at problem 7. If I were to plug in negative 1/3, what should I get as my answer? You should get 7. So I had 6x to the 4th minus 25x to the 3rd minus 3x plus 5. And I'm going to plug in negative 1/3. So again, use your calculators if you need to, particularly on this one.
Yeah, please tell me that college for
Okay, so this gives you 7, which is what we should it to give you, because 7 is your remainder. It doesn't necessarily happen a lot, but go back and apply that to what you learned here. If our remainder is 0, what does that tell us about the problem? It actually factors. So you could easily determine whether or not some polynomial is going to factor by plugging it in. So look at problem 9. And we're going to work this one kind of backwards, like the long way around. Not necessarily the long way around. But let's figure out what our remainder is first. We're going to figure out what our remainder is first, and then we're going to go back and actually do the synthetic division. So 3x cubed minus 2x plus 5. And what are we plugging in for x in this problem?
1.
Positive or negative?
Positive.
Positive. Why is it positive?
It's the opposite signs always change.
Opposite sign. So 1 and 1. So, well, we can do this one. That's easy because what's 1 cubed? 1. And 1 times 3 is 3. Negative 2 times 1 is 2. And then plus 5. What's 3 minus 2?
1.
Plus 5?
6.
Okay, so that means for our problem, for problem 9, what should we get as our answer when we do, or our remainder when we do synthetic division? 6. Okay, so finish problem 9.